Hey, this is going to be the first of a series of probably more advanced combined videos that I'm going to be recording. So the other day I was in a reactive Slack channel talking with David O'Hayan, and I'll link to his Twitter profile in the video notes. And he discussed adding an operator to combine that's kind of like prefix. There's a few prefix overloads that will go into that already ship with combine, but basically a prefix is for a certain window of time. So it's kind of like a windowing operator to where, like, for example, if you had an upstream publisher that was say streaming events, say from like the Twitter fire hose, and you want to kind of like peek into that fire hose and take like say 5 seconds worth of tweets and then kind of work with that segment of data. That's kind of what a prefix duration operator would help with. And to kind of give a sense of what combine ships with regard to prefixing, we can take a look at their docs. And if you go over to the publisher namespace, and then if we search around for prefix, we actually got 4 overloads. So we got prefix that accepts an integer, prefix while that takes a predicate, prefix until output from, which takes another output or takes another publisher, and prefix until that publisher emits. And we're actually going to be leaning on this one in our implementation. And then the last one is try prefix while, and that's basically the throwing version of prefix while. So prefix while takes a predicate, and predicates are functions from, or at least in this case, it's function from an output to a Boolean. And you kind of want to give consumers the ability to throw in that function. So that's what kind of the try overloads, if you see throughout combine, what they're doing. And so you'll notice that like prefixing for a notion of a duration of time is actually missing from the framework out of the box, and maybe Apple will fill this gap someday. But until then, we can actually compose our own operator to do that. And what's awesome is that Shai, and I'll also link to his profile as well too, has been running this library called CombineX, and I've been contributing to it for the past few weeks. But it's basically a community overlay of extensions, utilities, kind of custom subject conformances, publishers on top of Combine to kind of make it easier to work with. And this is kind of the result of all of the learnings the reactive community has had over the years prior to Combine. Combine borrows a lot of prior art from libraries like Reactive Swift and RX Swift. And they've all kind of, folks have made their extensions over the years. And this is basically a collection of them. And a lot of them port those extensions from RX Swift and Reactive Swift over to Combine. And maybe, like I mentioned earlier, Apple will fill in these gaps someday. But until then, we can kind of do that as a community. And maybe someday these will land in the actual framework itself. And what's awesome about prefix duration for the kind of time interval case is that it's relatively straightforward to create this operator, and we can do so composing existing operators in the framework, most notably that prefix until output from operator. And there's kind of 2 ways to create custom publishers. You can kind of compose existing operators, or you can actually like literally have your own publisher conformance. And conforming to publisher is pretty involved, and it's actually like, I guess, kind of even more involved than that would be conforming to your own custom or conforming to the subject protocol by yourself. And I do have some writing on this, and I'll link to that in the notes as well too. But for today, all we have to do is compose existing operators, which is relatively straightforward. And I'll kind of walk you through how I would PR this operator to CombineX, and also link to the subsequent PR after the video as well too. So to kind of get things started, I already have CombineX cloned locally. And you may notice a few groups in the sources directory. So we got our custom subjects, replay subject, for example. I got operators, some relays that Shai added, kind of shared models. And in our case, we're going to be adding a new operator. So we can go ahead and add a new file. So file, and then we'll call it prefix duration. Cool. And then we won't actually, we will need to import foundation because eventually underneath the hood, we're going to need to lean on a timer. And that timer type is in foundation, so we can't just solely import combine. We'll import combine as well too, because we'll be leaning on some existing operators. And when you're creating a composed operator versus a custom publisher conformance, kind of the first thing you need to do is extend the publisher namespace. And that's kind of where all the, you may have noticed in Apple's docs, if you actually go to the publisher page, you have all the operators kind of there. And what's interesting is that if you go for any given operator, say for example, filter, the method on publisher is in the publisher namespace, but it also returns a publisher's like plural with an S, and then usually like a type that represents that operator. And that's in the publisher's plural namespace, but we're going to be working in the publisher like kind of singular noun case. So again, now that we're in CombineX and we want to expose this extension publicly to folks who are using this library, we'll do a public extension, publisher singular, and we'll add a func called prefix And this will probably shake out in code review, but with regard to how we want to name this thing or kind of give it argument labels, I was thinking prefix duration, but I can see the argument for having an external label like for, so like prefix for some duration. But the only thing that's weird about this though is like, then at call sites, folks would be like prefix for one, and that may be a little bit confusing with regard to prefix one, which is kind of taking the first element from an upstream. So I think for now I'll do prefix duration, and then if that changes in code review, you'll see that in the linked PR. So we'll prefix for duration, and this is where we're gonna now need to lean on foundation. So we'll do for a time interval, and for now, and there's a lot of nuance that goes into this, but we'll return any publisher, and its value event type is gonna be output, and then its failure is gonna be failure. And for now, we can just fatal error to get things building. So you may have noticed that the output and kind of failure generics here were kind of auto-completed for us. And the reason that we're getting this is because since we're extending the publisher namespace, or it's actually, so underneath the hood, I believe it's, yeah, it's just the protocol. Since we are creating a method, we get to inherit those associated types from publisher, output and failure. And our, sometimes when you're creating an operator, you will need to mess around with like what the output type is or the failure type is if you're mapping on those. But with our prefixing operator, we're not changing anything about the publisher itself. We're kind of just like windowing certain value or completion events. So yeah, so we got things building now. And to start, we're gonna lean on that existing kind of prefix overload I mentioned. So we'll do prefix and then until output from. So one thing that's super handy is, so basically right here right now, we're gonna need to fill in a publisher that emits basically kind of after duration elapses. So the way that we can do that is to create a timer that basically kind of fires after duration. And what's really helpful is that, so we need to pass a publisher here, not a timer here, of course. So it turns out that combine, so foundation, I believe imports combine, and there is some overlays on top of some foundation types that kind of give them like a combine, like syntax or kind of interface to more easily work with. So there's actually a timer.publish method. And what's awesome about this is this actually returns a timer publisher that we can work with. So what we're gonna do is we're basically gonna say publish every duration, and we'll make sure it only fires once in a bit. And for now, just as a placeholder, we can say do it on the main run loop, and then the mode, we can just keep it default for now. And so one thing that is a little bit tricky is, so if we actually hop over to, that's not gonna work. If we actually hop over to timers docs and then find publish, and we go to timer publisher, and this is a bit of a nuanced topic, but timer publisher is actually, let's see, where is it in the docs? It's timer publisher. Yeah, it's actually a connectable publisher. Oh, here we go, cool. So it conforms to the connectable publisher protocol. And this topic is a little bit nuanced for this video, but I do cover it in my most recent article on replay subject that I'll also link to as well as Ed too. But the kind of the short story about connectable publishers is that usually for an ordinary publisher, when that publisher receives a subscriber, it kind of hands it a subscription right away. But with connectable publishers, that's deferred until later. So the reason this is handy is, like, for example, imagine we had a shared timer amongst, say, like 5 different subscribers. Those subscribers may be kind of created at different times in the view tree. So what this allows you to do is kind of like defer handing all those subscribers a subscription until that connect call is made. So if you actually go to the connectable publisher protocol, conformances are required to implement the connect method. So this timer is going to return a connectable publisher that won't start firing until someone calls connect on it, which in our case we're actually not really going to need, just because we're kind of acting as an external interface, and we're not exposing this timer to folks. We're just kind of saying, okay, like underneath the hood for this prefixing, we're going to be using a timer, but those details about the timer should not be like kind of controlled by external consumers. And again, connectable publisher is a little bit nuanced, but for now, the way you actually convert a connectable publisher back to an ordinary publisher is through the auto connect method. And so what we're going to need to do is, so if we actually were to try to work with it in this point, it wouldn't work. So we'd have to first do auto connect, and that'll convert basically from this line onwards to an ordinary publisher. And we could also test this as well too, but just for the sake of keeping the video short as well. We just want to just, as a safety, make sure that the timer only ever emits once. So what we can do is we can, yet again, lead on another prefix overload, and we can just take one event. So we could, or I'm sure this is how Combine handles it, but this until output from, whatever publisher it is handed here, I'm guessing after it receives one value event, it'll cancel that publisher, or it'll cancel the subscription that publisher hands the subscriber. But just to be safe, we can just take one value event. And that kind of, so now if we build, we still have one compilation error left, but that's really kind of the meat of this operator. And we can expose more options too about like kind of how you control this timer, and I'll do that in the final PR. But for now, this is kind of like the slimmed down interface of what the final operator will be. So we may notice this compilation error, and that's saying that the type of this publisher, which is kind of a nested, really gnarly composed operator, is not equivalent to an any publisher. And while this may seem cosmetic, so the way you'd actually fix this is to do erase to any publisher, and we should be able to Command B again. But there is some nuance here. What is nice about any publishers is that it kind of hides implementation details from consumers of your library. But by erasing, you're actually cutting off potential performance gains. And actually, I do write about this as well too, and I'll link to it in the notes. There's a notion of operator fusion, and that the idea kind of for short is that like if you return the folder type and then you subsequently add on operators to kind of that folder type, there are cases where Combine doesn't need to necessarily keep nesting over and over again. It can reach upstream and then kind of operate on that, and then kind of fuse. That's where the fusion part of operator fusion comes in. It kind of fuses types together. So by erasing, we're kind of cutting off the possible benefits of fusion. And you might wonder, is like, oh, is that actually really leaking kind of actual implementation details? So if we actually just swap this in for that any publisher, and Command B again, and if we hop over to prefix until output, aside from being a publisher conformance, where you kind of have that receive a subscriber method, and of course it's initializer, the only real thing it exposes, aside from a vanilla publisher, and in our case, in any publisher, is the other publisher that's going to be outputting that single value event, which in our case is the timer, and then also the upstream publisher. So if any consumer was leading on these details, they'd kind of be sidestepping the need for the operator in the first place. So like by returning the folder type here, even though it does look a little bit more messy, at the end of the day, this is still a publisher, and there's not really anything that a consumer could work with that full type. So the reason I like this, and of course CombineX is an open source community library, so like kind of if folks kind of prefer erasing, I'm definitely going to do that. But by giving the folder type back, you kind of allow for fusion to still happen. But by erasing, you're cutting off fusion. And while it is cosmetically nicer than this really gnarly type, again, like consumers really aren't going to be able to lean on it anyways. And so you also might have considered that we do have potentially a third option where you could say some publisher. So this is a little bit deceiving. If you Command B, this actually builds, but there's a problem here. When you actually try to use it at call sites, we kind of run into kind of a cyclical type inference problem. And I go into detail also about this in the operator fusion post. But the problem is that like some publisher basically says that the compiler underneath the hood, that this implementation is going to drive what type is being returned. But the problem is that some publisher needs to hydrate those associated types of output and failure. But that's coming from the call site because this is a method. So like this implementation has no idea what output and failure are. It's actually keeping them intact. But so like that's coming in from the call site. But then by saying some publisher, we're telling the call site that the implementation is in charge of dictating what failure and output are. So it actually runs into a kind of essentially like a cyclical inference problem. So even though this does compile, it is a little bit misleading because when you try to use it at call sites, you'll see that the compiler can't figure out what output and failure are. So before going down that rabbit hole, I have a post on it. We're just going to go ahead and go back to the folder type. And again, if this is not your cup of tea, you can totally go back to the erase to any publisher. Just know that you're possibly leaving performance benefits. You're taking them off the table, which may be okay for your application. But for CombineX, like we don't really know how folks are going to be using these operators. We kind of just want to like give them the most performant versions. And we don't know if like they're going to be tacking on operators after our prefix. So that's kind of why returning the folder type is a little bit more beneficial here. So there's a lot of nuance for a line, but of course it is one hell of a line. But in any case, it's just like a publisher. So that's really the implementation for it. So to recap, we're basically saying prefix upstream until we get a single output from this timer. This timer is only going to fire after duration elapses, and for now, we'll just do it on the main run loop and in default mode, and then in the follow-up PR, I'll go ahead and expose options for folks to customize that. We're going to auto connect onto it just to make sure it's like a normal publisher instead of a connectable publisher. And we're going to take the first events from that timer, just kind of as a safety net. I'm guessing I can do some more testing, probably follow up on this video to see if until output from cancels that subscription after receiving a single value event, but this is just extra safety. We might not need it. And that's really it. That's the meat of the implementation there. And that adds like I think it would be a 5th prefix overload. So if we go publisher and then prefix. Yeah, that would add a 5th prefix overload. Cool, so let's go ahead and test this thing. And yeah, that's kind of like the second step in adding any combined ext operator. So let's go ahead and go over to the test group, do new file, Swift file, prefix duration tests, and then we'll make sure it's in the combined ext test group. And so we're gonna need to import a few things. So we'll do ext tests first and foremost, and then import vanilla combine, import combine ext, and then go ahead and set up the class. So it'll be prefix duration tests, subclassing ext test case, and just make sure it's building. And shift U. Cool. So yeah, so the first thing to note is that in kind of all of the combined X tests, kind of depending on whether or not you're testing a operator or a utility that involves multiple publishers or a single publisher. In our case, we're going to be doing testing a single publisher at a time. We need to kind of hold on to the cancelable token that's returned whenever we subscribe to that publisher. So we usually tack on a private var cancelable, not private var cancelable, any cancelable, and we can, since it's private, it's this for a test suite, we can force and route for now. So for the first test, let's go ahead and test a single value event that comes in window of the prefixing. So we can say test value events in window. Cool. And kind of an easy way to set up sending value events and receiving them is to kind of use a subject as a bridge. And subjects are also another pretty nuanced topic that would take a while to cover, but I do have some writing on it. The replay subject post that I wrote most recently does cover the protocol in depth. So you can kind of use that as a starting point. So we'll use a subject as our bridge, and we'll do a pass-through subject, and we'll say, just for sake of testing, our value events are ints, and we'll never have an error just because we're in a testing scenario. So we'll want to do a couple things. And this is kind of the tricky part of this test that we'll be writing, is that since they are time related, unfortunately, this test will kind of need to wait. We'll basically need to do expectations and kind of wait and then assert. In reality, we'd probably want to do something like a test scheduler and some other kind of combined utility libraries like Entwine, I'll link to that as well too, have custom implementations of test schedulers. And what's really helpful about that is that it kind of lets you have virtual time. So your tests that deal with time-related operators can run basically synchronously and super fast. And you don't have to kind of deal with this like timeout and wait expectation dance. So unfortunately, Combine X does not have a test scheduler already implemented. I'm not sure if Shai has plans for this as well. But at the moment, like writing a test scheduler is really hard and tricky. And with WWDC, like kind of really close. I'm not sure if Apple is going to add it because the fact that they're missing it is a huge gap in the framework. It's really hard to test time-related combined code at the moment without a test scheduler built in. So I'd be hesitant for Combine X to add that type with WWDC so close. If WWDC comes around and we see that they don't add it, then it might be worth the investment in implementing one. But for now, like Combine X doesn't really have that many kind of time-related tests. We're going to have this suite, and then I believe the flat map latest tests, they also have some time-related stuff. Yeah, there's a timer here going on. So again, the test suite is relatively small. So like if we had like 100 tests that all were kind of waiting on expectations, that'd be really slow. But I think for our purposes, just keep things simple. We will use expectations, but just know that kind of the more robust way of testing time-related operators is with a test scheduler to kind of like virtualize the time. So with that aside, so we have a subject that we can send ints to, and then now we want to subscribe to it, store that cancelable token off, and then kind of send events in that window. So what we'll do is we'll do the subscription. So we'll do cancelable equals subjects dot prefix. So let's say we want a prefix for a 0.5 second window, and then we'll sync, and then we want to zoom in on both completions and values. So we're gonna need to set up an expectation, wait for all of our kind of events of interest to happen, and then kind of assert on certain values. So we need a way of kind of accumulating both values and completion events. So what we can do is we can say var values equals an array of ints, started off empty, and similarly for completions. And the subscribers.completion type takes a single generic, which is the error type. In our case, that's never. And even though it is completions plural, we could do a subscribers completion optional because we know we only ever get one, but either way is kind of relatively equivalent. It's not too big of a deal. So what we can do is whenever we receive a value event, we can go ahead and append onto values. So we can do values append $0, and then we can do the same dance for completions. So we can do completions dot append $0, and I think I got some extra parens there. And then we're gonna need to do something else as well too. So we're gonna basically need to block after the subscription is set up until we have that expectation fulfilled, and then we can do our assertions. So we can do this thing, say let expectation, I can spell XCT test expectation.init. Cool. And then what we can do is after we receive our completion event and we've appended it to completion, so we can say expectation.fulfill. Cool. And then we'll want to wait on it. So we can do wait, and then we'll only have expectation, and then let's say timeout is a single second. So what we can do now is, so right now we're not firing any value events. So we should be able to see xctest assert equal. We should see just a single completion. So we should say completions is equal to dot finished. So that dot finished comes from basically like, since we're prefixing for, let me tag this over. Since we're prefixing for only half a second, and we're not sending any events, and our timeout is 1 second, which is longer than that half second, we should only expect a single finished event on this test so far. So let's go ahead and give that a spin. Cool. But of course, we're not sending any values, and for this test, we want to send a single value. So let's go ahead and do that. So we'll do, so before our wait, we'll do subject.send, and we'll send a 1. And then what that will do is now we can basically say values should then eventually get that 1 down. So we're building, run the test again. Cool. And just to make sure that we're kind of not just having like a vacuously passing test, let's comment out that sending of 1 and just make sure this test fails. Sweet. Cool. So it didn't get the that 1 because we commented it out. Sweet. So awesome. So run this again just to make sure we're good. Sweet. So now we can do our next test, and that is let's do a value events outside the window. So instead of in window, do out of, I guess. Yeah, that's fine. So now what we'll want to do is, so if our window, say, let's bump it down to like say 0.25, we want to send an event after that window has elapsed. So what we can do is we can say dispatch queue dot async after, or we can do dot main dot async after. Cool. So we'll do now plus, and then so basically, so our window is 0.25 seconds. So let's add a half second, fire that event, and we shouldn't see it downstream. So we can do dot seconds 0.5. Sweet. And then now we can send our 1. Cool. And can do here is, okay, so our window's a quarter of a second. Let's do, cool. So our window is a quarter of a second, and then at the half second mark, we're going to send a 1. And we should expect that we don't get any values. So we can do true values is empty. And then we should only get that finished event from the window elapsing. So let's give that a shot. Cool. And this passes. And then kind of the way to make sure that we're that this, just that there's no like shenanigans going on with this dispatch queue async after, let's do, let's actually include the window just for, or let's include the value event in the window just to make sure it's happening. And then now we should get this assertion to fail. Cool. And yeah, it's false because it does have a value, and that's that one that came in. So cool. So now we should be back in passing order. Awesome. So we kind of need to consider 3 different possible events when it comes to publishers. We need value events, completion events, and completion events kind of split into 2, and that's the ordinary finished events successfully, and then the failure events. So let's go ahead and kind of now move on to those other 2. And of course we could test combinations of them, but just for the sake of time, we're just going to go through each of the classes. So let's do test finished event in window. So now what we can do is we're not going to be asserting on values anymore. So we can go ahead and ignore any kind of values related code. And then what we'll want to do is, so we want to send a completion in the window. So we'll take out the async code. We'll say subject.send, and you can also send completion. So we'll do an ordinary finished. We'll take out our values related stuff. So we want to send this finished will be sent right away. Our window is 0.25, and just actually for consistency, let's go back to how the other test was set up. So our window is half a second long. We should expect 1 finished event within that window. And just to make sure that we can disambiguate between the one that we sent and the one from the window expiring, what we can do is we can have this expire, or this timeout be, say, like 0.3. So this is before the window completes. We should still expect that finished event to come through. So if we run this, weird. Okay, cool. So this does pass. So what this means is that we're not hitting that 0.5 kind of timeout finished event. We're actually getting the one that we sent kind of honestly before that happened. So, and the reason that we need this, so we actually let's just demonstrate why we need that. So if we commented this out and say went back to that 1 second timeout and ran this would still pass, but that's a little bit of a false positive because the finished event we're getting is the one from the window expiring, not necessarily the one that we want to test that's in range. So that's kind of why I bumped up that timeout. So let's do in window. So let's do one out of window. So we'll keep this here. We'll do dispatch queue.main.async after.now plus. So our window, let's bump it down again to 2.5. We'll do now plus 0.5. We'll execute. We'll send a finish event. So we want to make sure. Yeah. So we want to make sure that the finished event that we're timing out on, so 0.3 is longer than the deadline, or of the duration deadline, but it is before the kind of the manual one we sent. So we want to make sure that that finished event comes through by that point in time. So let's go ahead and test this. Cool, that passes. So this kind of asynchronous one is coming beyond our expectation being fulfilled. So we can go forward with that. So that wraps up our finished events. So now we can go move on to failures. And that's going to kind of essentially mirror these 2 tests, but just subbing out finished events for failure events. So let's go ahead and do that. And we'll need basically an error type for both of these tests to lean on. So what we can do is we can do like a private, or yeah, I think we do private. I don't know if we'll need to do file private, but private enum, let's call it an error, conforms to Swift's error protocol. Well, case some error. We can basically swap out, and then just to get things, we'll do them one at a time. I'll comment this out. So we'll do, instead of a never, we'll do an error here. And then we'll synchronously send a failure some error. And then we should expect to see that on the other side. And then let's compile. So now we need to do test failure event in window. Cool. So let's go ahead and run that. That passes. Sweet. So now we basically want to do the same dance, but now doing the failure event outside. So we'll basically kind of do the same thing. Nevers get swapped in with inner. And we'll do failure events out of window. We'll want to send it asynchronously. So now we're not actually going to want to change the assert equal here, because if we send a failure after the duration deadline has passed, we should still finish successfully. We shouldn't actually see a failure event propagate through. So if we build the test target and run this test, which you see that pass. Cool. And yeah, that pretty much cool. That pretty much wraps up all the tests that we can. And again, we can also do combinations of these things. We can do like multiple value events in window, one out of window, and then a finished event out of the window, stuff like that. But essentially, this is kind of the core of the test suite here. And I'm going to tidy this up a little bit so we can go back to prefix duration. So one thing that's missing is that if we want to give call sites control over this underlying timer, we can basically go into timer.publish's interface. And of course that might not work. So let's go to timer, publish. So there's like the every, which is what we're leaning on, is also a tolerance, the run loop, the mode, and schedule options. So we can also expose those options to consumers and essentially just like pass them through and not necessarily modify them in any way. And yeah, that'll kind of give folks more control over the underlying timer that we're going to be using and kind of how it's running. And yeah, when it comes to contributing to Combine Next, this is kind of the main two parts. There's kind of writing your operator, make sure it's publicly available, and kind of a way to gut check if it is publicly available is to like not testably import Combine Next. So in our case, we don't have a testable import, and we're able to compile. So we know as a consumer, we know this interface is available. And then also updating documentation. So one thing left out is we have no docs here. So we'd want to tack on docs on prefix duration. And then also in terms of like actual like documentation to help folks use Combine Next, there is a README, of course, and there's a bunch of different sections, one for operators, publishers, subjects, and different utilities. So we basically need to sorry for saying basically twice, we need to add another entry here for prefix duration. And yeah, that pretty much wraps it up. So hopefully this kind of demystifies contributing to Combine Next. I'll link to the final PR. And yeah, thanks again to David Ohayon for, I don't know, sorry if I'm not pronouncing that right, for the idea for this operator. And hope it's helpful. Thanks, y'all.